Okay, so just briefly summarizing what we just said, power functions are of the form y equals x to the p. Exponential functions of the form y equals b to the x. Difference is where the exponent, where the variable is. Here you're taking a power of the variable. Here the power is your variable. Okay? It's in the exponent. Your power is the exponent. That's what makes it exponential, and you don't want to confuse the two. There's a huge distinction between power and exponential functions that even people who are supposed to be mathematically semi-literate confuse often in stuff I see on the internet, where they ought to know better. People don't understand the difference between power and exponential. Okay? Take the coronavirus. It tends to be exponential. That's much worse than if it's got power function behavior. So it's not exactly the way the disease control people approach it, but if you can make it into a power function, it's not hard to control. So you put various controls in place, you can kind of get it. You can kind of reduce its exponential behavior, and then you can have less disruption. Okay? Okay. So we have these functions anyhow. Your basic power functions are the x squared, x cubed. The reciprocal function, because that's x to the negative 1, and the reciprocal square, because that's x to the negative 2. We know what the graphs look like. We also have the inverse of the cubing function. And of course the square root is the 1/2 power. Square root of x is x to the 1/2, cube root of x is x to the 1/3. So those are power functions with fractional powers. Okay? See, now, can anybody think of any of our basic functions that's exponential? Well, you might say the basic exponential function. And you certainly would. Okay, just to give you a chance. Okay? Basic exponential function is what well, that's how we've referred to it. If you put a different number in there for 2, you get a different exponential function, but the graph is going to look very similar. Okay? And we've actually looked at the 3 to the x function. And I've asked you to do that, at least once for homework. And it's very simple. 3 to the x function, you just make the table and graph it. It ends up a lot steeper than the 2 to the x function. It still has the same basic shape. Okay? Okay. Now, we'll be talking more about exponential functions soon, probably within a week. But right now we're going to talk about polynomial functions. Left the word out. It's a sum of multiples of power functions. The powers are all whole numbers. And that means non-negative integers. And that means 0, 1, 2, 3, 4, 5, and so forth, right? The counting numbers, but also with 0. So, example. (5x squared plus 7x plus 3). Now, what kind of a function is that? It's quadratic, but quadratic functions are polynomials. Okay? Okay, because x equals x to the 1 and 1 equals x to the 0, excuse me. Okay, these are positive integer powers of x, right? So these are power functions with positive integer powers, okay? Another example. I mean, I write down anything I want to here, as long as I use positive integer powers, and as long as I understand that just a plain old number is that number multiplied by x to the 0, which I've demonstrated here, so I'm not going to write it out here. And just plain old x is x to the 1. So all these are multiples of power functions, and you're adding them, okay? Now, you'd say, I'm adding them, why do I have a negative there? Well, I'm adding negative 3x to the 5th. And negative 3x to the 5th, you cannot quarrel with the fact that that is a multiple of a power function, right? And I'm adding it. Okay? Yeah, you can quarrel with it if you want, but so we can write it this way, and I'm probably going to ask you to do that on a couple of problems. I'm going to give you a couple of problems, just says write this out showing all the powers. Okay? I don't think you're going to have any trouble doing that. But I want to reinforce that because I don't want you to lose track of that. So you know what a polynomial is. You don't know what to do with it, but you know what it is. You don't yet know how to graph it. And actually, I probably don't know how to graph that one because I can't factor it. Okay? Now, okay? Now, I don't go to the trouble of teaching a lot of factoring of polynomials. Okay? Takes up a lot of time, and there are more important things to lose sleep over, because you usually can't factor them. Any polynomial that comes at you from the real world, you're not going to be able to factor the blame thing. But you got to know what the factored form of a polynomial tells you about its graph and about its behavior. So, example. There's a polynomial. And this is completely factored. I should put another word in here, irreducible quadratic factors. Okay? By irreducible, that means that you can't factor it over the real numbers. Which means if you set it equal to 0, you don't get a solution. You don't get a real number solution. Remember, you always get a complex number solution. Okay? So if you set x squared plus x plus 9 equal to 0, you can figure out the quadratic formula, the discriminant b squared minus 4ac is going to be 1 minus 36, negative 35. You're not going to get a real result. Okay? So you can't factor this on real numbers. And we'll deal more with that later. The point is, this is a linear factor. And leave myself room, but let's just put a 2 in front of that x. It's a very bad looking 2, and it's getting worse. It doesn't just have to be an x minus or an x plus, okay? That's a linear factor. That's a linear factor. This is quadratic, right? And this is irreducible. And if I did this one, first one, if I multiply all this out using the distributive law, it's going to take a few steps, right? But I could do it, and so could you. They're probably going to ask you to do it for homework. Now, they're getting way too much homework to do for Thursday, so I'll be a little more specific about what I want Thursday and what can be delayed, okay? Because I know you only have so many hours a week. But I expect some hours between now and then, okay? You really need to do it. Okay, more next time.